Today in the physics lab, we're going to be looking at the lab for the optics table. Now for this lab, you'll notice I have it pulled up on the screen. For the virtual lab, the main difference is we're going to be using mystery materials A and B, which you will find in the virtual lab. So everywhere in this procedure where it says, rhombus or water, we're going to replace those with the rhombus will be mystery A, and the water we'll call mystery B, because it's going to be your goal to find out the index of refraction of those two materials are. So here, be sure to read the actual procedure when you go through the lab. We're going to start with the virtual lab, so I can go ahead and bring that up, and we're going to click the intro. Now, our goal is to find the index of refraction for these two materials. So I'm going to go ahead and switch from water down here to mystery A. You'll notice that we have a laser here. It goes from here to there. And this dashed line here is the normal. So before we can really do anything, we need a protractor to measure the angle. So you'll notice there's this, you can put this protractor anywhere, but you want the 90-degree line to be right here on the surface, and you want the 0-degree line to be right there on the normal. It doesn't matter if it's perfect, but the closer you get, the better. So if we look at our procedure here, it says that we're going to have to align all of this stuff. Again, some of that's more for the lab, but basically we need to measure these three angles, or we need to send the laser in at these three angles and measure the angle of refraction, okay? And then we're going to use that to calculate later on the index of refraction. Now, each one of these should give us the same index of refraction, but it might be slightly different depending on how we measure it. And then last but not least, we need to find the critical angle. So again, where it says rhombus, think mystery A, and where it says water, think mystery B. So here, you'll notice that when I send the laser in, I see, when it hits the surface, I see two beams. This is obviously the reflected beam, and this is the refracted beam. So we only need the angle of refraction because, again, the angle of reflection should be the same as the angle of incidence. So for example, if I went to 10 degrees, that would be just right here. That's about 10 degrees. And so here, coming out, I'd say that's maybe 4.5. So maybe I'll write 4.5 down in my lab notebook. And so the laser passes out, and then I can, later on, you'll use Snell's law to calculate that index of refraction. Okay, so you'll do this for 10, 30, and 60, then switch materials. Now, let me go over real quick of how to do the critical angle. And remember, the critical angle is the angle at which the refracted ray no longer occurs. Basically, the angle is too high and it won't come out. Now, if you'll notice here, I can go all the way down basically to 90 and everything's fine. Okay, so even here right before 90, I still see just a little refraction. Remember, you can only have a critical angle when you go from a material that's more dense to a material that's less dense. So our mystery A and B their indexes of refraction are higher than air, so we're going to have to switch these. So here, if I switch to mystery A on top and air on bottom, well, now I can pretend like the laser's in there, and so the critical angle will be that angle at which we only have a reflection. So here I didn't, I've obviously gone past the angle, so don't try to write that down. You're going to have to do it on your own. But again, you want to find that angle where it just starts to do this, because anything above the critical angle will always totally internally reflect. And then after that, make sure you answer your analysis questions and have a good day.